And welcome to the second Steno lecture, Extraterrestrials, the Science and the Theology. My name is Heather Foucault-Cam, and I am the Program Director for the Science and Religion Initiative at the McGrath Institute for Church Life at the University of Notre Dame. I am honored to moderate today's discussion, which is co-presented by the Society of Catholic Scientists and the Science and Religion Initiative at the McGrath Institute. We are co-sponsored by the Harvard Catholic Forum, the Lumen Christi Institute, and the newly created Polish chapter of the Society for Catholic Scientists. Today, we will have two presentations. First, Professor Lunin, and then Professor Baglow, and we will conclude with a live question and answer session, incorporating a selection of pre-submitted questions. As we prepare ourselves today, I'm reminded of the homily given by St. John Paul II at the beatification of Niels Stenson, also known as Nicholas Steno, the patron of this lecture series. St. John Paul II instructed that Niels Stenson's whole life was a tireless pilgrimage in search of truth, both scientific and religious, in the belief that every discovery, even modest, is a step forward towards the absolute truth, to the God of the universe on which everything depends. This vision that proceeds from the most intimate point of man and which embraces his reality, intellect, will, and emotions, opens him to the transcendent experience of a personal encounter with God. Being mindful of these words, I would like to ask for the intercession of Blessed Nicholas Steno and St. Albert the Great, whose feast day is tomorrow, as we begin our work today. So let us begin in prayer. In the name of the Father, Son, Holy Spirit. Amen. God, our refuge and strength, you gave the sainted bishop and teacher of the Church, Albert, the power to associate human knowledge with eternal wisdom. With his intercession, strengthen and protect our faith in the intellectual confusion of our days. Give us the openness of this intellect so that the progress of science may also help us to know you more profoundly and come closer to you. Let us grow in the knowledge of the truth which you yourself are, so that we may someday see you face to face in the presence of all the saints. For this we pray through Christ our Lord. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. Without further ado, it is a privilege to introduce our first speaker to you. To begin, Jonathan I. Lunin is David C. Duncan Professor in the Physical Sciences at Cornell University and Director of the Cornell Center for Astrophysics and Planetary Science. Professor Lunin does research in astrophysics, planetary science, and astrobiology. He is a member of the U.S. National Academy of Sciences and, among other awards, is the recipient of the Jean-Dominique Cassini Medal of the European Geosciences Union and the Basic Sciences Award of the International Academy of Astronautics. He is the author of Earth, Astrobiology, a Multidisciplinary Approach, and Earth, Evolution of a Habitable World. Professor Lunin is Vice President of the Society of Catholic Scientists as well. I would like to invite Professor Lunin to give his presentation focusing on extraterrestrials from the scientific perspective.
Heather, thank you very much. And it's a great honor to be asked to give half of the Steno lecture and to tag team with Professor Baglow. I'm going to share my screen now and begin. So I am an astronomer at Cornell University. I'm actually now the chair of the astronomy department there and have worked in solar system and extrasolar planets for over 35 years. And in the short 20 minutes that I have, it's going to be impossible for me to give you a full sense of what we have learned over that period of time about our place in the universe from an astronomical perspective. But what I am going to do is try to convince you that we know very little about the possibility of extraterrestrial life beyond the Earth. And yet we have a number of ways that we can perhaps reduce our ignorance, if not completely eliminate it. So let me begin by addressing just very briefly what is so fascinating about extraterrestrial life. There are many different aspects to this question. There's the cultural self-reflection. What is our place in the cosmos? And has our biological or cultural evolution been affected in some way by extraterrestrials? Have we been visited? The second question has led to innumerable, mostly entertaining, but not so edifying, books on the subject. One that I enjoyed as a kid was The Spaceships of Ezekiel, written by a retired NASA engineer who put forward the idea that Ezekiel's great visions were in fact of an alien visitation and not of the glory of God. From the scientific point of view, the question of whether extraterrestrial life exists can produce a number of different detailed questions. For example, how commonly can life form in the cosmos? And is self-awareness a rare or even singular property? Is it something that comes naturally out of the evolution of organisms, or is it something that we possess uniquely, or if other species possess as well, is it something that we possess due to divine intervention? And finally, the theological implications, the question of whether non-sentient life, either microbial or even non-sentient animal life, is really not an issue in our Catholic faith. One only has to consider the superabundance of creation, of God's creation on this earth, and then think of the existence of life elsewhere as a natural extension of that. And the sense of wonder that we derive from that, and the sense of wonder that we are at the same time deserving of special attention of that creator. The lines of Psalm 8, for example, that we read this morning if you did the morning prayer. But sentient ETs, what I'm going to call, and Professor Baglow is calling ETRSs, extraterrestrial rational species, might pose some interesting issues for Christianity, in particular the Catholic faith. And Marie George wrote a rather detailed and serious analysis of this in a book entitled Christianity and Extraterrestrials that I found an interesting read, although much of which I did not necessarily agree with. So let me move now to the scientific side, and my role in this is to sort of set up the theological questions by asking how much we know about the probability that extraterrestrial rational species actually exist. And from a scientific point of view, the answer is we know nothing. And let me try to motivate that with a discussion of some of the factors that go into a question of the number of extraterrestrial intelligent and self-aware species that might exist elsewhere in the cosmos. And those factors were famously collected together into a kind of a formula called the Drake equation, invented by Frank Drake in the 1960s, the famous radio astronomer who was a pioneer in the search for extraterrestrial intelligence by radio. This is a formula that doesn't predict a physical effect or attempt to explain experimental data. It's simply a way of taking the number of civilizations in our galaxy that one might expect to be present, to be able to communicate with us at any given time, and then list out the factors that would go into that number, a number, of course, that we do not know in any sense. So those factors are first R subscript star, which is the rate of star formation in our galaxy. Then that's multiplied by F subscript P, the fraction of stars that have planets. And then N subscript E is the average number of planets that can potentially support life for each star that has planets. And then F subscript L, the fraction of those habitable planets where life actually does develop. And then F subscript I, the fraction that go on to develop intelligent life. And then F subscript C, the fraction of those that are willing and able to communicate. And then L is the lifetime of such a civilization. So since R is a rate, number of stars formed per time, and L is a time, N is a number, and the rest of these are just fractions, you get a number out of this, which purports to be the number of civilizations in our galaxy at this given time. So here are the numbers that we know. We know two numbers. One is the rate of star formation in our galaxy. And if I confine myself to stars that are like the sun, that's a few stars per year in our galaxy. Stars much more massive than the sun fuse hydrogen, burn hydrogen so quickly that they would go unstable and explode before life has a chance to actually begin or evolve toward intelligence. and stars that are much less massive than the sun, even though they're also much more abundant in our galaxy, arguably might not be great places for the development of intelligent life, because those planets need to be so close to those stars that those planetary atmospheres would be subject to very severe effects like coronal mass ejections or stellar flares. So I'm going to leave those out. The other number that we know is F subscript P, the fraction of those stars that have planets. And remarkably, that number, roughly speaking, that fraction is unity, or 1. That is, for every star in our galaxy, there is, roughly speaking, a planet. Now, that's a number that 20 years ago we did not know. For centuries, people have wondered about this. There were speculations, of course. Giordano Bruno's famous statement, which was remarkably accurate, that among the innumerable stars, there are innumerable planets, but he said we can't see them because they're lost in the glare of their parent stars. And that is, in fact, the case. And it was only since the mid to late 1990s that astronomical techniques have become sensitive enough that planets can actually be detected around other stars. And now we know that planets are an extremely common outcome of star formation. So that number is 1. The rest of these we do not know, although N subscript E is something that we're beginning to approach with modern astronomical telescopes. So let's spend about 5 minutes playing a game. And let's pretend first that we're optimists, and then we'll pretend we're pessimists. So let's be optimistic and say that in any given stellar system, since every stellar system on average has a planet, let's say that every one of those planets can support life, that in every stellar system there's a planet that is habitable, that can support life. And then let's say that of those planets that can support life, the chance that they go on to develop life is 100%. Again, we're being optimists. And that life inevitably evolves to form intelligent life. And that intelligent life inevitably is of such a physiology and nature that they are willing and able to communicate. And let's say that the lifetime of such an intelligence is 1 million years. And I picked 1 million years because that's the average lifetime of mammalian species, although obviously these things would not be mammalian in the sense that we think of it. But let's take 1 million years. And what I get is, for sun-like stars, we expect to have today existing 3 million civilizations that can communicate with us, essentially a Star Wars or a Star Trekian type cosmos. Problem with this, of course, is that radio signals have not been found, and if there are so many of these civilizations, why aren't we hearing from them? So let's now be a pessimist, and let's say instead, I'm going to leave N subscript E as 1. I'm going to say that it is fairly common that planets actually are habitable. We could make that number 1/10 if you like, but it doesn't really matter. Let's then say that only 1 out of every 1,000 of those planets actually goes on to develop life. And I'm simply making that number up because I don't know the answer to it, and I'll explain why in a couple of minutes. And let's say that the fraction that go on to develop intelligent life of those 1 planets in 1,000 that develop life is 1%. Again, a number I made up. Let's say that 3% of those are willing and able to communicate. The rest of them destroy each other before they invent radio telescopes, or they live in the sea and they can't see the sky, whatever you like. And then, even if the lifetimes of such civilizations are on average 1 million years, we're alone in our galaxy. Now, why would I be justified to take that kind of pessimistic view? And in particular, as far as the origin of life itself goes, the answer is I have no justification, because, as I'll argue in a couple of minutes, we really do not know how easy or difficult it is for life to form from non-living chemistry. But let me address the question of the development of intelligent life, because one of the startling things that has been learned from the scientific investigation of the geological history of the Earth is that it took a very long time for humans, for self-aware intelligent life to evolve. So this very simplified, very schematic timeline I'm putting here is a distillation of an enormous amount of work over many decades on the geological and chemical and biological evolution of the Earth, and doesn't do any justice to that work, but it's very schematic. And it's ticked off here in billions of years. So today is 4.56 billion years after the Earth formed. We have that number very, very well pinned down. And I'm going to go out to the future, about 6 billion years. So the geologic record tells us that water appeared on the Earth not too long after the Earth formed, maybe 1 to 200 million years. And life began on Earth certainly within the first billion years of Earth history, and maybe the first half billion years of Earth history. Very, very quick, first 10 to 20% of the Earth's history. First complex cells, what we call eukaryotic cells, which have organelles like mitochondria and chloroplasts, or cells like what we're made of, at least the animal version. They show up in the record maybe about 2 billion years ago. And then there's a 2 billion year gap between that, at least 2 billion year gap between the development of the kinds of cells that we are made of and the first animals, the first coordinated, differentiated, cooperative cellular organism. The time period in between, where almost nothing happens evolutionarily, is called by geologists the boring billion, or the boring 2 billion. And why it took so long is unclear. There are speculations that the oceans of the Earth were highly sulfidic, and that made life difficult, that the Earth was plunged into several episodes of deep glaciation, nearly extinguishing life. But whatever, the first animals don't show up in the fossil record until 80% through the history of the Earth. And then it would be another essentially 500 million years before humans show up. Now, for those of you who know something about stellar evolution, you might yawn and say, well, so what? The sun's main sequence lifetime is about 9 or 10 billion years, so that's only halfway through. Not bad. But in fact, the Earth is likely to become uninhabitable long before the sun goes off the main sequence. The reason for that is that the sun's luminosity is gradually and steadily increasing with time due to the physics of nuclear fusion and the balance of forces inside the sun. And climate models that simulate the Earth's surface as the sun increases in luminosity predict that the surface temperature of the Earth will become hot enough for water to evaporate and be lost to the stratosphere and then to space within the next 500 million to billion years. So remarkably, if these models are right, it took 80% of the entire habitable history of the Earth for self-aware life to form. And if it turns out we are precocious, then it may well be that time runs out before, on a typical planet, there is the evolutionary formation of self-aware intelligent species. Now that's a speculation, and let me get even more speculative. Let me get really pessimistic and assign numbers like 1 in a billion for F sub L, or 1 in a billion for F subscript I. If I do that, even if I consider the rate of star formation not in our galaxy, but in the entire cosmos, multiplying by all the galaxies that we know of in the universe, or that we estimate are present, then even there, we're alone. So at this point, you might feel enraged, or you might laugh and say, this is ridiculous. My point is that we don't know what these numbers are. The numbers that we know are R subscript, R asterisk, and F subscript P. And N subscript E is something that we can learn from the next generation of space telescopes, like James Webb Space Telescope. They can actually look at planets around other stars and tell us something of the composition of their atmospheres. But the other numbers we have no way of knowing. And there's no argument that one can make that would tell you that you need to pick numbers close to unity. In fact, physical systems don't naturally pick probabilities close to unity. The decay of the proton, for example, which is a necessary part of the extension of the standard model of the universe. If you want to have an excess of matter over antimatter, protons had better decay, but they decay on timescales of 10 to the 34 years, which means that the probability that any given proton will decay in the age of the entire universe is 1 over 1 divided by 1 over 1 followed by 24 zeros, 1 trillion trillion. So these numbers can be anywhere. And because we only have one occurrence of life that we know of, we cannot estimate the probability that a habitable planet will be able to form life. In fact, one of the great successes of genomics has been to determine the genomes of a wide range of organisms, from the simplest bacteria and archaea to the most complex organisms like human beings. And what we find is that they're basically all the same, that it's almost inarguable that all of life on Earth had a single common origin, that there was a bottleneck somewhere very early in the evolution of chemical systems toward life, or maybe just after that point, where there was a single last universal common ancestor. And so what this tells us is that life that we see today on the Earth is a single form of life. And so we have only one example of the formation of life, one example of this phenomenon. And in the absence of a convincing laboratory model for how life forms, that means we are completely ignorant of the probability with which this would happen on any other given world. In fact, Carl Sagan quotes in a book in 1966, Intelligent Life in the Universe, quotes the American physicist Philip Morrison, who was at Cornell at the time, that just discovering life on one other planet would transform the origin of life from a miracle, a singular event, to a statistic. And so it's that we want to do. There are two ways to do this. One is to shortcut and do radio telescopic searches for extraterrestrial rational species. That is being done, and the results so far are negative. And with this kind of search, a negative result really doesn't tell you very much. A positive result would tell you a lot. But I want to focus my last few minutes on looking for simple life elsewhere, looking for microbial life, because finding another independent origin of life anywhere else would give us an indication that this parameter, F subscript L, is not very, very small, that it's actually a number that might be close to 1, especially if we find that result in our own solar system. So where are the places that we might look for life? Well, there are a number of worlds that have or once had liquid water on their surface in our solar system. There's Mars, which once had liquid water. And there are 3 moons in the outer solar system, Europa, Jupiter, Enceladus, and Titan, where we know liquid water exists under the surface today. And I'm going to focus for the remaining time on Mars and 2 of those moons. So Mars today is a dry, dusty place. The surface is uninhabitable. It's bombarded by ultraviolet radiation. This selfie photo by MSL Curiosity at Gusev Crater shows what Mars looks like today. And yet the Curiosity rover, as well as a number of other spacecraft that have explored Mars, have found ample evidence that liquid water existed in the first 500 million to billion years of Mars history. And so life might have formed at that time. The next rover, the Mars 2020 Perseverance rover, is headed toward this area on the edge of Jezero Crater on Mars, where a delta formation, which is now dry, demonstrates that large amounts of liquid water were present inside that crater, and it's possible that we might in fact find evidence, fossil evidence of life. And I want to point out that Nicholas Steno, blessed Steno, for whom this lecture series is named, invented the principles of stratigraphy, geologic stratigraphy, and exploration of Mars by rovers now, the Curiosity rover in particular, finding, in this case, wind-deposited sediments on Mars, we're using the very principles that Steno invented for geology on the Earth, and using them today on Mars, which I find to be a remarkable statement about how far we've come in the scientific exploration of our cosmic neighborhood. So let me now turn to these 2 moons in the outer solar system. Europa is the first one for which an extraterrestrial ocean was discovered. It's almost as large as the Earth's moon. The ocean was discovered by the Galileo orbiter using sensitive magnetic field measurements of what are called induced magnetic fields that were stimulated by the time-varying Jupiter magnetic field. They demonstrate that there's a large ocean with some salt in it. That ocean is in contact with silicate rock based on the density of Europa. The rest of this, what we need to know about whether this ocean to determine if it's habitable, we do not know. We don't know if there are carbon-bearing molecules. We don't know if there are chemical reactions occurring at the surface, of the rocky core, the interface between the ocean and the rock. These are things that require a subsequent space mission to determine. On the other hand, the other moon, Enceladus, a moon of Saturn, is a moon whose ocean we know a lot about. That ocean was discovered by the Cassini spacecraft. Again, like Europa, it's underneath an icy surface, an icy crust. But that ocean is expressing itself into space through a series of jets, which you see here, that are composed of dust, ice, and gas. And the Cassini spacecraft not only imaged these, but actually flew through the plume that was formed by these jets. Here's a distant view of that plume, and measured the composition of that material with a mass spectrometer and determined that it is frozen salt water from the ocean, and determined that there are organic molecules present, carbon-bearing molecules, and minerals that indicate active chemistry between a rocky base of that ocean and the ocean itself. And so by all standards that we can apply today, this ocean underneath the surface of Enceladus appears potentially to be habitable. And so the possibility that life might be detected there has stimulated a number of proposals to go back to Saturn's moon Enceladus and fly through the plume with instruments that could detect biomolecules, molecules that were produced by biology and ejected from the ocean through this series of jets. And NASA has not yet approved any of those missions, but if they do, we might by the 2030s have a second place in our solar system where, if the result is positive, we know that life is formed. And in that case, that factor F sub L would be a number that perhaps is not small, but is considerably close to unity. And so that's as much as we know at the moment. We don't know if the cosmos is teeming with self-awareness. We don't know if we are unique. But we have ways, scientific approaches, to looking for life elsewhere and approaching the answer to this question, even if we never receive a signal from an extraterrestrial intelligence. And it was Blessed Nicholas Steno himself who said, beautiful is what we see, more beautiful is what we comprehend, and yet most beautiful is what we do not comprehend. And with that, I will turn things over to my colleague, Professor Baglow, to talk about the theological implications of extraterrestrial life. Thank you.
Professor Lunine, on behalf of all of us, thank you very much for your presentation. At this point in time, I would like to introduce our second speaker for today. Professor Christopher Baglow teaches in the Theology Department at the University of Notre Dame and is the director of the Science and Religion Initiative at the McGrath Institute for Church Life. He is also on the executive board of the Society of Catholic Scientists and is head of its Theological Advisory Committee. At Notre Dame, Professor Baglow creates and directs programming that helps Catholic teachers and leaders to bring faith and science into dialogue for the sake of the new evangelization. He has led programs of academic integration at 2 Catholic high schools, including the STREAM program at St. Mary's Dominican High School in New Orleans, Louisiana. From 2011 to 2014, Professor Baglow directed week-long seminars for Catholic science and religion teachers called the Steno Learning Program in Faith and Science, which was funded by the John Templeton Foundation. Professor Baglow is also the author of Faith, Science, and Reason, Theology on the Cutting Edge, the very first textbook on the relation of science and faith ever written for use in Catholic high schools.
Afternoon or evening to everyone, depending on where you're watching this video from. My name is Chris Baglow, and I'm very thankful to the Society of Catholic Scientists for asking me to speak on this intriguing topic, as well as Heather Foucault-Cam, our facilitator. And above all, I want to thank Jonathan Lunine, Professor Lunine, for graciously sharing with me in advance of his recording his compelling and clear explanation of the science regarding the possibility of extraterrestrial life, which gave me something to base these reflections on. Theology is faith-seeking understanding, and so it needs input from all of the other disciplines, and in this case especially astronomy, to understand the universe God has created. As speculative as the question of extraterrestrial life might seem to some, such questions allow theologians to return to the foundational principles which animate all good theology. As I was preparing this talk, a quote from Robert Jastrows' famous book, God and the Astronomers, kept coming to mind. In that 1978 book, Jastrow chronicles the discovery of the Big Bang Theory and the new cosmology that it revealed, a universe expanding from a real beginning in time. In that regard, he wrote, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he's greeted by a band of theologians who have been sitting there for centuries." Now, in regard to the possibility of extraterrestrial life, Jastrow's comment might fit. Christian philosophers and theologians really have been thinking about this possibility for a very long time, longer than modern science has been around. Take, for example, the great 15th century philosopher, theologian, and Cardinal Nicholas of Cusa. Cusa theorized favorably about the existence of intelligent life on other planets, which he thought was probable due to God's creativity. "We suspect," he wrote, "that the inhabitants of the sun are more sun-like, more enlightened, illuminated, and intellectual. We suppose them to be more spiritual than those that are on the moon, who are more moon-like. Finally, on the earth, they are more material and gross." And in a very interesting comment, he counters any doubters by saying this: "Certain people have said that on Earth there are as many species of things as there are stars. Therefore, if in this way the Earth contracts the influence of all the stars into distinct species, why would there not be similar occurrences in the regions of other stars which receive stellar influences?" In that interesting quote, you can see that he envisions a natural origin to life versus what we would, see today as creationism or some kind of miraculous intervention, and also almost prefigures the modern realization that all of us are made of elements generated in the cores of stars, of stardust. Now, the church taught nothing definitively in Cusa's day and has not taught anything since about extraterrestrial life. But she by no means discourages theologians from engaging in speculation about the prospect and how that prospect relates to revealed truth. The first question we have to ask is, how does a theologian speculate on something for which he or she has no doctrinal guidance? In that case, we have something much more essential than doctrine to guide us. We have theological principles. The principles that St. John Henry Newman identified as the underlying life of doctrines, animating them much like the soul animates the body. Those principles were so important, Newman thought, that he considers them a better test of heresy than doctrine. Principles are assumptions, habits of mind. Doctrines are objective professions, conscious articles of faith, but they flow from theological principles. In my presentation, I will enumerate 3 such principles that suffuse and are illustrated by the great sweep of salvation history, the principles of sacramentality, particularity, and solidarity. And on the basis of those, we'll speculate about the religious histories of any ET rational species. I will use the shorthand ETRS for that phrase many times in this talk, assuming that they exist. The first of those principles, sacramentality, comes from Newman himself. It's among the 9 examples of theological principles that he gives in his essay on the development of Christian doctrine. But he also notes that there are many others. And so I'm proposing 2 more that are helpful and that I think are incontestably essential because they are the very grain of God's action in history. So here, in a nutshell, is what I'll be talking about and arguing. From the first principle of sacramentality, which I also calls the principle of incarnation, I will argue that the divine Son of God would speak through living representatives of ETRSs, and that the thrust of that speaking would ultimately be toward a fullness of presence among them in an ET incarnation, regardless of the question of sin. There would be prophets, lawgivers, psalmists, elders, and sages sent by God, and ultimately an incarnation in whatever body God had provided that species via evolution. The second principle, particularity, refers to the divine tendency to deal not first with the grand scale, but with the small scale. Not, for instance, in our case, the grand scale of humanity, but with a particular people, the Israelites, and to keep going smaller, ultimately dealing with one tribe of that people, Judah. Then after the exile, one fragment of that people, those who return, the poor faithful ones or the remnant of Israel. And then with one woman in one small town, the Blessed Virgin Mary. That God does things this way is scandalous, or has been scandalous to many. It was certainly scandalous to the anti-Semitic journalist William Ewer, who once wrote, "How odd of God to choose the Jews." I love the biting rejoinder he received from the American journalist Cecil Brown, which, as you will notice, retains this particularity, but not so odd as those who choose a Jewish God yet spurn the Jews. At any rate, I'll argue from this principle that such an incarnation would be singular for each ETRS, because the Lord seems to choose one for the sake of all. And finally, the third and most important principle. Charity, as God has revealed, means willing the good of another for their own sake. And solidarity is the perfection of charity, in which a lover longs and does take upon herself or himself the situation of the beloved, to be intimately united to them in that situation as possible. From the third principle, I will argue that the actual historical path of the incarnate Lord in solidarity with any ETRS would be determined precisely by the need of that ETRS. For an unfallen species, that historical path will look quite different than how it looks when God enters into solidarity in an incarnation with a fallen species like ours. And I'll speculate on that difference. And with that, I'll conclude, and the floor will be open for the questions you have submitted, for which I will be live, along with Professor Lunine. When we discuss ETRS, we are not discussing angelic creatures, but embodied ones, in particular, rational animals like us. According to St. Thomas Aquinas, angels receive understanding directly from God, and contemplating the divine essence, they come to know all things. Embodied creatures do not experience the divine in this way. Rather, we experience the divine as mediated through material means. Even those who see apparitions in the Church's history see something bodily, even if that is offered merely as an accommodation to their senses. Now, we can only extrapolate from our own evolutionary history in regard to ETRS life, or extraterrestrial life. Our situation reveals that the closer to rationality on the neurological level creatures are, the more social they are. Think of dolphins, orcas, the great apes, and, as has been discovered recently, the highly intelligent octopods and corvids or crows. It's not surprising to a Catholic theologian that the closer to intellect and freedom, to love and truth, a creature advances on the neurological level, the more social they become. For God is Trinity. God is one but not solitary. The implications seem to hold that, like us, ETRS too would live in societies, within communities and cultures. They would engage in symbolic discourse, both verbal and material, and in that way they would image the divine Son, who is God's very word, verbum, and wisdom, and so would have some history in which God makes himself accessible to them, culturally, historically, and in embodied ways. And so, I argue, setting aside the question of sin on other planets, that there would be prophets, lawgivers, psalmists, elders, and sages for every ETRS. There would be prophets, because prophets speak the divine word in ways that are contextual and specific to the life of persons. and even sinless creatures live in particular circumstances. There would be lawgivers such as Moses, because law is not necessary simply to curb evil, but to structure society in a way that is conducive to the growth of virtue. And virtue is the fruit of living. Even Christ, we learn in the Gospel of Luke, could grow in wisdom and favor before God and man. There would be music makers and poets, because the whole universe is charged with the grandeur of God, and beauty, goodness, and truth must be celebrated, whether or not that praise is dispersed through and through with songs of lament, as they are in our case. There would be elders and sages who would distill the fruit of experience, which is wisdom, in practical and speculative ways. I know nothing of ETRS sexuality, but if it is like ours, all these would be male and female. And I tend to think that if the ETRS was unfallen, not with sin, there would be female prophets, lawgivers, psalmists, elders, and sages a lot earlier and a lot more frequently in ETRS history. But ultimately, there would be one who is not only fully ET, but fully God. It would be this one who would draw together and fulfill all that the great ones spoke and did, because God can be no more perfectly mediated than by mediating himself, as a divine person who is fully God and fully ET. Whether or not there would be sacraments embodying him depends on whether or not there would be a need for salvation, or perhaps there would be sacraments of a different order. I'll get back to that. For now, we can conclude our consideration of this principle and go to the next, which will help us answer this question. If there are X number of rational ET species in the universe, how many incarnations would there be? Based on the principle of particularity, I speculate that for every ETRS there would be one and only one ETRS incarnation. I think this based on the pattern of God's action in history, on the unity of the church on earth, and on the embodied nature of ETRS. First, the divine pattern we see throughout human salvation history, as I said earlier, is that God chooses small for the sake of all. He engages one people in all of their particularity to be the focal point of the unity he desires for the whole human race, and to them he adds the many. And when God chooses one to save the many, he does not do so in a way in which the many are dominated or subjugated, but rather elevated. Thus, what is called the scandal of particularity is only a scandal when one misconceives the God who chooses and or the reason for his choosing. By choosing to become one ET for one ETRS, the divine Son would unite himself to the many and the many to each other. That last point goes to the particularity of that many, or rather the bringing together of that many. In our case, this particularity of salvation history continues in the church, which is one mystical body of Christ, because there is only one incarnate Lord. In the opening paragraph of the Vatican II Dogmatic Constitution on the Church, Lumen Gentium, we read, "The Church is in Christ like a sacrament, or as a sign and instrument, both of a very closely knit union with God," and this is the key part, "and of the unity of the whole human race." Going along a little bit further in Lumen Gentium, in number 8, we read, "Christ, the one mediator, established and continually sustains here on earth his holy church, the community of faith, hope, and charity, as a visible entity through which he communicated truth and grace to all. For this reason, by no weak analogy, it is compared to the mystery of the incarnate Word." Well, from these quotes, I hope you can see that the idea of incarnation and ecclesial unity in a visible communion are closely related. The proportion is one visible incarnation to one visible communion of believers. Were there multiple ET incarnations for any one ETRS, that ET church could not be the one sacrament of the unity of the whole ET race. To these considerations, we can add that any ETRS would be like us, both physical and spiritual, a unity of body and rational soul. My great teacher, Father Rat Koreshi, pictured here with my daughter Margaret, by the way, Margaret's the one on the left, in his excellent book on Christology, in a section entitled Why Only One Incarnation, captures why we should expect only one ET incarnation per ETRS, based on nature. Here I alter his words for the sake of showing that what he says about human nature can also be applied to ETRS natures. So let's consider his wise and beautiful words. Remember, I'm subbing in ET here. He says human. ETRS are both the spiritual and physical, or more exactly, the essential unity of soul and body. God makes his absolute fullness reside in one limited ET being at one point in the space and time of ET history. Therefore, it seems providential that the cornerstone of ET's religious history should be both visible and invisible, physical and spiritual, concrete enough for all ETs of one species to relate to one of their own by learning his words and finding a home in his heart. Therefore, based on what we know of divine election, of the small for the sake of all, of the one for the sake of many, both at the level of the incarnation and also of the church, and of the church as the sacrament of the unity of the human family, and also, obviously, the embodied nature of ETRSs, if they exist, I propose the following formula. X times 1 plus 1 equals I, with X being the total number of ETRSs ever in the history of the universe, and I equaling the total number of total number of incarnations of the divine word. Okay, that's all the math I have in my presentation. The principle of solidarity is our next point. So far, I have used foundational principles to conclude A, that for any ETRS, there would be a true salvation history culminating in an incarnation, and B, that for every ETRS, there would be only one incarnation. But if any of those ETRS were fallen like ours, would there be any salvific act, such as another death and resurrection on the part of the incarnate Lord? This brings me to the issue of solidarity as the perfection of Christian love. As I said in my introductory comments, love or charity, the theological virtue, means willing the good of another for their own sake. And solidarity refers to the perfection of charity, in which the lover longs to take upon herself or himself the situation of the beloved, to be as intimately united to them in it as possible. An incredible example and powerful example of this that comes to mind for me is the Jewish convert St. Edith Stein, who felt that her call as a Christian was to be in solidarity with her people. 10 years before she would be executed with them in Auschwitz, she felt a call from the Lord. In her words, "I told our Lord that I knew it was his cross that was now being placed upon the Jewish people, that most of them did not understand this, but that those who did would have to take it up willingly in the name of all. I would do that with them." She spent her last days in Auschwitz caring for the children of the other women who had been arrested. As one survivor said, she went among the women like an angel, comforting, helping, and consoling them. Many of the mothers were on the brink of insanity, without giving any thought to their children. Edith Stein immediately set about taking care of these little ones. She washed them, combed their hair, and tried to make sure they were fed and cared for. This is solidarity. To not only feel compassion for the beloved or even to serve them, but to be united with them, to enter into their situation. That solidarity is the principle undergirding the doctrine of salvation through Christ's passion and death. In Romans chapter 5, verses 6 through 8, it tells us, "For Christ, while we were still helpless, yet died at the appointed time for the ungodly. Indeed, only with difficulty does one die for a just person, though perhaps for a good person one might even find courage to die. But God proves his love for us in that while we were still sinners, Christ died for us." An important axiom of Christian soteriology, the theology of redemption, is that the personal history of Jesus Christ is the triune life of God reenacted in solidarity in time and space within our human history. God descends in the incarnation to take us up into that life, to make us partakers of the divine life, because God is love and solidarity is the hallmark of perfect love. As any parent knows, love impels them to try not only to help their children see the world as it is, but also further to see the world through their children's eyes. And it's in doing so, paradoxically, that parents fulfill the task of elevating their children to the status not simply of sons and daughters, but of friends. For the greatest triumph of parenting is to produce adult children whom you are proud to call your friends. And so in the case of any ETRS, fallen or unfallen, we should expect that the Lord would make their lot his own. Now, in our case, as a fallen as a fallen rational species, this means something both beautiful and terrible. As the great Dominican theologian Herbert McCabe once said in his masterpiece, God Matters, the story of Jesus is nothing other than the triune life of God projected onto our history, so that or enacted sacramentally in our history, so that it becomes our story. I use the word projected in the sense that we project a film onto a screen. If it is a smooth silver screen, you see the film simply in itself. If the screen is twisted in some way, you get a systematically distorted image of the film. Then he continues. Now imagine a film projected not on a screen, but on a rubbish dump. The story of Jesus, which in its full extent is the entire Bible, is the projection of the Trinitarian life of God on the rubbish dump that we have made of the world. That the Trinity looks like a story of, is a story of, rejection, torture, and murder, but also of reconciliation, is because it is being projected out on, lived out on, our rubbish heap. It is because of the sin of the world. Because God is love, any ET incarnation would be no mere show. Be it a joyous incarnation with no suffering and death for an unfallen species, or one in which, like ours, there is horrifying tragedy, although ultimate triumph. It would be the lover searching for and uniting himself to his beloved in each and every case. Now here I find my job of theological reflection is at a fork in the road, and only one of the forks is fully accessible to me. Let me start with the barely accessible road, imagining what an incarnation among an unfallen ET species would look like. In order to adequately imagine that, I would have to be much, much holier than I am, and even then I would have no clue what a preternatural sinless state or community would be like. So I'll just point out some misconceptions that I think many people have about what our life on Earth would have been like had there been no fall. I'm going to quote myself in this regard from my textbook on faith and science. Quoting oneself is, by the way, what fallen creatures like me do. When trying to conceive of what preternatural existence would have been like, with original integrity and freedom from suffering and death, our imagines can tend to run away with us. Some think of the first humans living in an earthly paradise in which our planet, or at least some region of it, was radically different than it is. A place where nothing ever died, and in which no physical evils were present. But it is more helpful to think of Eden as the privileged way in which sinless humans would have existed in this world as it is, or at least as it was at the emergence of the first fully human beings. Others assume that freedom from death would have meant a perpetual lifetime for humans on Earth. But many important theologians, including St. Augustine, thought that eventually, had our first parents not sinned, they and their sinless descendants would have entered into a glorified state, comparable to the risen Christ, or to the Blessed Virgin Mary after she was assumed body and soul into heaven. Still others assume that freedom from suffering would have meant freedom from any pain whatsoever, and a situation in which humans would not need to strive or mature in wisdom and virtue. But this also has never been the teaching of the Catholic Church. That's all I have for that road. But for the other road, the one I tread myself and that we all tread, the path of sin and redemption, of purification over a long period of time, I can imagine more. For a fallen ETRS, there would be some painful sacrifice on the part of the ET Messiah. There would be resurrection and the establishment of a gathering community to bring the ETs together in one communion, out of their estrangement and alienation from God, from others, and from themselves. This community would have sacraments, symbols which affect the very graces that they signify. There would be forces that endanger that community from within and without, but also a promise that the gates of ETRS hell would never prevail against it. I could go on, but hopefully that you see that in short, there would be a mystical body of ET Christ. From there, we can let our imaginations run wild. What would the sacrament of initiation look like for an entirely aquatic ETRS? Would they be taken out of the water 3 times rather than plunged into it? How would Eucharist be different? Would there be more sacraments than 7 or less? Questions suggest themselves in abundance, and no compelling answers come to my mind at least. Perhaps our Q&A will surface some. But remember the difference between curiositas and studiositas, between curiosity and studiousness. Curiosity is a vice. Studiousness is a virtue. Instead of indulging curiosity, let me leave you with a poem that I think captures what the situation would be like after any ET incarnation. It's chock full of images of our planet, this poem, but it works for either an unfallen ET species or a fallen ET species. It speaks of a world that in every nook and cranny reveals the splendor of its creator. And although an ET biosphere might be strange to human eyes, it would still be wondrous in its own ways. It is an untitled poem of Gerard Manley Hopkins, and with it I will conclude. As kingfishers catch fire, dragonflies draw flame. As tumbled over rim and roundy wells stones ring, like each tucked string tells, each hung bell's bow swung finds tongue to fling out broad its name. Each mortal thing does one thing and the same, deals out that being indoors each one dwells, selves, goes itself, myself it speaks and spells, crying, what I do is me, for that I came. I say more, the just man justices, keeps grace, that keeps all his goings graces, acts in God's eye what in God's eye he is, Christ. For Christ plays in 10,000 places, lovely in limbs and lovely in eyes not his, to the Father through the features of men's faces. Amen and thank you.
Thank you very much, Professor Baglow, for your wonderful presentation. Friends, at this moment in time, what I would like to do is begin the live question and answer session. So to begin, Professor Lunine, this question comes to you from Chris Robb at the Catholic University of America. Are there any tools planned to be implemented in the next 10 or so years in the search for signatures of life on exoplanets? If such signatures, would those be phosphine related, were found, what would exoplanet researchers do next to learn more about the solar systems thus identified or signified?
Great, thank you. The first opportunity that we will have to look at the composition of the atmosphere of any planet that's even close to the size of the Earth is going to be with the James Webb Space Telescope, which will be launched next year, 2021. It's a large infrared space telescope. It will be put quite far from the Earth so that it remains cold and is not doesn't suffer from the infrared heat signature of the Earth. And with that telescope, it will be possible to measure the composition of the atmospheres of planets somewhat the size of the Earth, but probably larger. If the sensitivity of the telescope turns out to be better than expected, it could be Earth's. But let's take phosphine. For a body that's about 10 times the mass of the Earth, about 2 or 3 twice the size of the Earth, twice the size of the Earth. You could detect phosphine in that atmosphere with the Webb telescope after some tens of hours of observation, assuming that the phosphine had an abundance that was on the order of tens of parts per million up to tens of parts per billion up to a part per million. Put that in perspective, that's somewhat more than what we have in our own Earth's atmosphere. So it could be a biosignature that potentially is detectable, but it's going to be right on the edge. And the other thing about phosphine is that it may have a volcanic source. If you've got a very reducing mantle, you could produce phosphides that in the atmosphere could be converted to phosphine. So it's a real challenge. It's a challenge that possibly we could start to undertake to solve with the Webb telescope. But I think it's going to take the next generation of telescopes after that in space with much, much higher sensitivity and resolution to really get at these trace species. one molecule like phosphine is not going to be enough. You're going to have to look for methane and other signatures as well, but at least it's a start. So I hope that answered that question. Let me really quickly go through a couple of simple ones here that people asked. Yes, the Drake equation assumes all the factors are independent of each other. That may not be the case, but for the purposes of this talk, it was the most straightforward way to describe those factors. Many people really thought that 1 million years was too long for the survival of a technological civilization. I agree with that. I was trying to be provocative. And finally, there was a dialogue between Dr. Curlin and Dr. Laredo about the ocean in Enceladus. And Dr. Laredo was involved in a seminal paper establishing the existence of that ocean. Wanted to make one comment about it. We have evidence from Cassini, from the mass spectrometer that detects both dust and ice, for the presence of very tiny grains of silicon dioxide coming out of those plumes. And those grains of silicon dioxide are telling us that there are high temperature reactions, probably about 50 or 80 degrees Celsius, going on in the rock where the water is cycling through the rock underneath. And what is heating that rock? We don't know. It may well be the force of Saturn's gravity, so-called tidal heating, as Enceladus is squeezed and tugged as it moves around in its non-circular orbit around Saturn. But that's an intriguing piece of information that right at the base of that ocean, there are some high temperature reactions occurring. And I'll yield the floor now.
Thank you, Professor Lunine. This question I would like to propose for Professor Baglow. It is a pre-submitted question from Peter Aglione, a graduate of St. John's University in New York. And along the lines of what you discussed in your presentation, Professor Baglow, Peter's asking about would intelligent human-like life know the Blessed Trinity by necessity? Would they have a relationship to Christ? What would salvation look like for this species? And I know you touched on this in your talk, but would you like to add anything further?
Sure. Well, I would just point out, although I didn't say it explicitly, that when I talked about an aquatic extraterrestrial rational species being taken out of the water 3 times, it was because it would be in the name of the Father and the Son and the Holy Spirit that they would be baptized. In other words, for God to reveal himself would be for God to reveal himself as Trinity. Consequently, in all cases, they would come to know God as Trinity. That would be at the heart of God's self-disclosure to that species. So yeah, so I would say absolutely in that regard. And I didn't want to go as far as to say what would occur if these species came together and found out that they each had an incarnation of the Lord, right? And how that would relate. It was just far too far from my imagination. So I decided to be more modest. So yeah, that's all I have to say about that.
Brilliant. Thank you, Professor Baglow. We have a question, perhaps both of you would like to weigh in on, from Leszek Rozakowski, a physicist in Warsaw, Poland. And it begins like this. He can imagine that organic life exists elsewhere in the universe. We already know that there are many planets even not too far from us. We know that the mechanism that led to the creation of the solar system of planets is quite simple and robust. And he's convinced that planets are probably as abundant as stars, and that some of the life exists on some of them as well. However, there seems to be a key question whether highly intelligent life, like that of humans, can it all develop without a spiritual component or simply a soul? So I guess the crux of the question here is, could an ET civilization develop without an immortal soul? What would that look like?
So let me take the physics part of that question and leave the rest, the most interesting part, for my colleague. So again, as I said, it's very important to remember that in the last 20 years, there's been a revolution in astronomy where planets around other stars are now detectable by multiple techniques. And the most successful of those, the transit technique, has been pursued by the Kepler satellite and now by the TESS satellite. And what those results are telling us is indeed planets are as abundant in our galaxy as stars are. You can't count every planet, but by looking at the sample in the nearby volume of space, it's possible to conclude that planets are as abundant as stars. Now, does life evolve on those planets? What fraction of those planets are habitable, can support life, and of that fraction, what fraction of those planets actually does life begin on? Those are the things we do not know. We can begin to get an answer to the first of those parameters, again, from telescopes like James Webb Space Telescope and its successors. But the other question, whether life itself arises naturally on planets where life can actually exist, that's a question that's a big unknown. And I will then allow a leap to Professor Baglow to answer the rest of that question.
Sure. Well, here we actually do have doctrine to guide us. In the church's discussion of evolution from the very beginning, the qualification that the church has made about evolution of human beings and of human origins is that it would have to involve God in some very direct and special way. Even the words special creation of the human soul are often used. That we can evolve and neurologically, biologically from earlier species, but that at some point, God would have to be present to us in such a way that we become rational, because a spiritual soul, a rational soul, cannot evolve from matter. Now, when I say that, I want to say that I do not think that we have to think about this in a very crude sort of way, as this God is up in heaven shooting a soul cannon every time there's a human conception, right? But actually seeing God operative through secondary causes, the parents, human parents, in such a way that what they produce naturally, biologically, actually that as causes, they are made by God to transcend their ordinary capacity biologically. And therefore, the child that they produce is also a rational soul, right? Made in the image of God. So I don't think we have to think about this as God, kind of some coming from the outside, but rather transforming from within, the act of human conception. So for an ETRS, the same would have to hold, right? Because they would have a biological evolution. They would also need God's direct involvement for a spiritual soul.
Thank you for that, Professors Lunine and Baglow. Professor Baglow, we have a question from Robert Curlin, and he asks, in his trilogy, C.S. Lewis presumed no fall for the inhabitants of Mars and Venus. Consequently, there was no incarnation. Is this a possibility for ETRS situations? Could you, and we have a couple of questions about whether the fall is a necessity on ETR with respect to ETRS civilizations. So could you
Sure.
put those together?
Yeah, so that's an excellent question, because it brings up some of my favorite books by C.S. Lewis. And he does not envision an incarnation on those planets. He thinks of incarnation as something that is tied uniquely to soteriology. God becomes flesh in order to save fallen creatures. But in the Catholic tradition, there have been others who have thought that, for instance, Duns Scotus, that God would have become incarnate, and the whole Franciscan tradition for that matter, that God would have become incarnate to be one with us, even had human beings not fallen. I tend to go in that direction. I think that because of this logic of solidarity, which is at the heart of God's life, that he would want to be united with a rational species as closely and intimately as possible. And that would include sharing their flesh. So that's the way I go. But like I said at the beginning, this is speculation without much doctrinal guidance to rely on. So doing the best I can with what I've got.
Thank you. That was excellent. If we can return back to Professor Lunine and phosphenes, I was wondering if you could very briefly discuss what your thoughts were about the detection of phosphenes on Venus that made the news certainly very recently. If that is, just just a chemical occurrence, or if there's some possible biological link. If you could just comment on that finding, we'd be very grateful.
Sure. So very briefly, phosphine is the element phosphorus with 3 hydrogen atoms attached to it, so pH3. And of course, phosphorus is a very important element for life. It's the bonding element for DNA and for the energy currency that we call adenosine triphosphate. Anyway, it's not easy to produce pH3 in the kind of environment that we see on the Earth without biology, because that phosphorus tends to get bound up with oxygen. And the same might be true for the environment of Venus, but I'll get back to some possible exceptions to that in a minute. So anyway, back in September, there was a paper published using radio telescopic observations from 2 facilities, one James Clerk Maxwell telescope and the other the new ALMA telescope, in which the authors found evidence for phosphine in the atmosphere of Venus. Now remember, the surface of Venus today has a super greenhouse effect. The temperature is above the melting point of lead. Water is only a trace species in the atmosphere. The surface is not inhabitable. But high up in the atmosphere, perhaps 50 or 60 kilometers or 30 or 40 miles above the surface, maybe there's a layer of sulfuric acid with some water in it, and there's speculation that goes back to Carl Sagan, actually, that maybe a kind of life could exist in that. So finding pH3 in this atmosphere, even though in very, very, very trace amounts, was very exciting and led to some speculations about the possibility of life. Now, two caveats about this. One is that not everyone believes that those detections were actually very secure. And so there are several groups looking now at some possible ways that the spectral signature might be due to something else. So stay tuned for that. And the other is that there really are ways to produce phosphine other than with life. If it turns out, for example, that the interior of Venus, what we call the mantle, has a different amount of oxygen, a different oxidation state than the Earth. And this is actually work that my graduate student has been doing, among other groups. Then in volcanism, volcanoes, and we strongly suspect that Venus has some volcanic activity today, you would produce something called a phosphide, which is another compound containing phosphorus. And by reacting that with sulfuric acid, as shown by some experiments that were actually done recently in China, it would be easy to convert those phosphides to phosphine. So I think the jury is out, number 1, on whether the phosphine is really there, and number 2, whether it indicates life or not. There's a lot of interest in continuing to explore Venus in greater detail than has been done so far. And so maybe we'll see a robotic mission to Venus in the next decade or so, motivated by these discoveries.
Thank you very much, Professor Lunine. If we could turn to Professor Baglow, and this question brings up the concept of the Trinity, Professor Baglow, and this is from Trevor Stone. And he says, I know that the Trinity is 3 divine persons in 1 divine essence. Jesus Christ, our Son, is the Son of the Trinity. If each ETRS has an incarnation, how does that fit into the Trinity, the Trinitarian understanding? Do they take the place of the Son, or do they fit in another way? So I was wondering if you could just elaborate on how this ETRS would fit into our knowledge of the Trinity, please.
Sure. Well, I think each incarnation would be an incarnation of the divine Son. Going back to the fathers of the church, the idea here is that the Son is the very word, the wisdom, the reason of God through whom the universe is made. And consequently, he's one who becomes flesh and reorders creation when creation becomes fallen, right? Brings things to their fruition as well through the outpouring of the Spirit. So the Spirit is not left out of this equation, right? The Spirit is given to us and mediated to us through the incarnation of the Son. So in that regard, I think in each case, there would be incarnations of the Son. And this is not a problem for God to become human right, is not like God becomes human while he's God, because God is eternal, right? So I don't think that there's a problem of multiple incarnations, nor did St. Thomas Aquinas, who wasn't thinking about ETs, but thinking about multiple human incarnations as something possible for the power of God. Can I add something else, Heather? Um, so Ted Peters brought up something about John Paul II disagreeing with me with ensoulment. Um, I don't think we have to interpret John Paul II's concern here as portioning out the origin of any given human being, such that God is giving this part and the parents are giving that part. In the words of the International Theological Commission on this very question back in 2004 during the pontificate of John Paul II, the ITC said, with respect to the immediate creation of the human soul, Catholic theology affirms that particular actions of God bring about effects that transcend the capacity of created causes acting according to their natures. That's what we're talking about here, the direct creation of the human soul. But then it goes on to say, the structures of the world can be seen as open to non-disruptive divine action and directly causing events in the world. God ordinarily acts through secondary causes, even in miracles. And so consequently, human conception, which is a natural event in the course of nature that's very much like a miracle, but is actually a part of the normal course of nature, which other miracles are not, does not necessarily mean that God has to somehow come from the outside, but can come from within the act of conception. The key part here, to meet John Paul II's concern, is to say that the effect of that would transcend the capacity of the created causes that are the parents acting according to their natures.
Thank you for that. I'm wondering, considering one of our aims in this discussion series is to consider issues at the intersection of faith and science, if we can now consider one of our pre-submitted questions for both of you that is relying on, is teasing out precisely that. And the question is given to you from Tierney Verdoliak. Sincerest apologies for that mispronunciation. What is the best way to introduce the intersection of faith and science in a STEM environment? And I would argue, really, in any kind of interaction at all. What is the best way to approach this intersectional?
Professor Lunine, Jonathan, you want to go with that first?
No, you wrote a textbook on this. You can go ahead. I'm not. This is your book.
Well, I wrote a theology textbook. You know a lot more about STEM. But okay, in Foundations New Orleans, which is our summer seminar for science and religion teachers, we actually developed it for STEM teachers. And we have presentations that involve, or parts of the program rather, that involve scientific experiments that kind of raise big questions. We have one on evolution. We have one on order and symmetry and the laws of nature through flame testing of metal salts, which is a chemistry experiment probably every scientist has done at one point or another. And we also do wave-particle duality as kind of a natural parallel to the paradoxical that we find within divine mysteries. And so we do science, and then we meet together to discuss what might be the implications of that, what does theology provide, and try to bring together a unified picture. So I would say that's the best I can offer on that. But Professor Lunine, you may have more.
So I would actually like to answer that question by answering another pre-submitted question, if that's okay. And that's from Cara McBride. Why do you think the vastness of the universe is so scary for so many of us? And my answer to that is, it is only scary if one does not believe in a God who is both transcendent and immanent, a God who loves us and created us, and who has for us a destiny that is eternal. In the absence of that faith, I think it is possible to feel lost in this vast universe. And so for me, as a scientist and a Catholic believer, I both revel in the wonder of the things that I'm thankful and privileged to be able to investigate as a scientist, and also grateful and thankful that I can wake up every day and give thanks to the God who created me, and for whose love, which suffuses the universe, we can all be sure that we are in fact in his hands. And that's how I would answer that question.
Thank you very much, Professors Lunine and Baglow. For Professor Lunine, if we return again to measurements taken by spacecraft and extraterrestrial life, we have a question from Sylvia about the evidence for extraterrestrial life, what we look for, and then a question that complements that rather nicely comes from the chat, where we are being asked, supposing there is life on the surface oceans of Europa or Enceladus, what sort of measurements from the Europa Clipper or a dedicated mission are we looking for to show habitability in those oceans? So could you speak to kind of what we are looking for with respect to habitability?
Sure. So for habitability, that's the ability of a planet or a moon to actually support life. And so there, it's a question of, are we looking for life as we know it, which requires liquid water, or some exotic form of life? And since I don't have a lot of time, I'm going to stay with life as we know it. We look for liquid water. And in addition to liquid water, we look for the elements that go into the biological polymers that make life possible, the structure of life, the information carrying molecules, the energy transducing molecules. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are the main ones. And so we look for those. And we look for evidence of chemical reactions. And we see all of that on Enceladus. And so the question then becomes, what do you look for to find evidence of life itself? And there are two ways to go about that. Because we can directly sample this ocean, it's a much simpler problem than trying to look at the signatures of molecules in atmospheres of planets around distant stars. That's an important thing to do, but it's more difficult. For Enceladus and for Europa, you would look in the samples of the ocean for large molecules, hopanes, for example, which would be kind of a slam dunk. Or you would look for patterns of classes of molecules, like amino acids, for example, where that pattern of abundances is not what you get from non-biological chemistry, where that pattern is not determined by the ease with which those molecules are made, but rather by their utility in forming certain kinds of structures. And of course, we have experience with that only for the Earth, but there are ways that one can extrapolate that to other places. And then ultimately, if you can actually discover a cell coming from the ocean, which is harder to do, then that's a slam dunk, because now you actually have the organism itself. So that's what you look for with direct sampling. With Enceladus, it's easier because the stuff is coming out into space. For Europa, we don't have good evidence for that kind of emission of jets or plumes, but Europa Clipper may find that for us. If those don't exist, it may be that one has to send a lander to Europa near one of those fractures and try to sample the ocean directly. So that in sort of 2 or 3 minutes is the general strategy.
Thank you very much for that. We do have a question from Piotr Homila at the Institute of Nuclear Physics, the Polish Academy of Sciences. And he asks, in the case that ETI exists and we meet each other, we probably should be willing to evangelize and baptize them if they agree and or ask, should we be doing this? And there are questions within that question, there's this discussion of, you know, that intelligence being artificially generated versus extraterrestrially generated. So I was wondering if we could talk about the idea of baptizing extraterrestrial life and whether the existence of synthetic intelligence, how that would fit into that discussion.
Absolutely. So were we to meet extraterrestrial ET and ETRS, right? And it was apparent to us that they had no salvation history and needed one, then I think it would be obvious to us that in God's divine wisdom, he wanted us to be the ones that brought the gospel message to them, right? But we should obviously look rather carefully to make sure that our judgment of that situation is correct. We'd have to know the nature and something of the history of that ETRS, right? And we could join them in a cosmic hymn of praise, if in fact that was the case. So yeah, and then who knows? Maybe that that encounter, if they're not following, would benefit us a heck of a lot more than it would benefit them. So yeah, so that would be my answer.
And I want to be conscious of everyone's time at the moment, but I'd like to ask a follow-up question. In the chat, there's been several, and I can't attribute this to a single individual, apologies, but there's been several comments about self-awareness, rationality, and the soul. Could we just briefly, for the sake of the audience, would you kindly just fit those pieces together for us, please?
Absolutely. All creatures that have a nervous system are to some degree self-aware. There seems obvious to me, especially in the higher animals, that there's something like consciousness and self-awareness. You see it best in domesticated social animals like dogs. And I don't have a cat, so I'll bracket whether or not it shows up there too. But anyway, you have something like self-awareness there, right? When I talk about rationality, though, I'm talking about something that makes moral consciousness possible and freedom possible. Not only the ability to make judgments, what St. Thomas Aquinas saw that animals could make wonderful practical judgments, right? But to be able to make judgments about our judgments, to be able to stand back from them and think to ourselves, I did this, but should I really have done that, right? All of us had the experience of growing in wisdom where we look back and say, well, that seemed like a perfectly fine idea to me at the time. However, as I look back now, I was really remiss morally, remiss in regard to goodness, and and we become more aware. So that's the kind of rationality that I'm talking about here. Not simply something that comes to, now, obviously that is a very unique kind of self-consciousness, self-awareness, in which one can actually see oneself, stand back from oneself and see oneself and on one's actions objectively as much as possible, although our passions oftentimes cloud our ability to do that. So that, I think, would be the key thing for me in calling any ETS an ETRS. And we could say more, but I think, and there's a lot that's been written about that kind of thing, but that would be, I think, just a basic idea of what I would argue here.
Thank you very much, Professor Baglow. And Professors Lunine and Baglow, I want to be conscious of everybody's time, but there's one final question I would like to ask from Jorge Ledezema, and that is, if we pause for a moment and think, what will the news of extraterrestrial life, speculatively, what impact will that have on people's faith, or how we see the universe? Do you care to comment on that at all, both of you?
Well, I'll just briefly comment. I think that there won't be a single reaction that one can characterize. People will have many different reactions. Again, from speaking from the point of view of my faith and the faith of many people on this this lecture series here, discovering life elsewhere in our solar system, or that other planets are habitable and may have life, just as an expression of God's superabundance and infinite capability to create an enormous variety of life, not only here, but also elsewhere, as is the case for all the species that once lived on Earth that are now extinct. It's not a challenge to my faith, it's a reinforcement of that faith. From the practical point of view, discovery of microbial life that had independent origin would be incredibly exciting, both from the point of view that I described before in my lecture, but also potentially the applications to understanding how our own biology works, and even potential pharmaceutical and other kinds of applications. So I think, at least for the microbial life part, it would all be positive.
Yeah, one of the things that I read just to develop my reflections was an article by C.S. Lewis that I'd never heard of before, called Religion and Rocketry. And it's a fantastic thing. It's on a collection that I think is out of print, called On Fern Seed and Elephants and Other Essays. In that, he notes that at one time, it was thought that we were alone in the universe. And opponents of religion took that as an example that we were nothing special, just an accident on some, in some bywater of the universe. And then scientific opinions shifted, even in his own day, towards thinking that there were many, many species. And opponents of religion said, there you go. You see, we're nothing special. There's life all over the place. You can see the problem, right? If one's not willing to challenge one's deeper assumptions, then they're not going to change their mind, regardless of whether or not we find ET or not. And I guess at this particular time in American history, I'm very pessimistic about people's ability to change their opinions about anything. But you get the idea, right? That there's sort of that there are deeper questions, and this is why we should never rely simply on discoveries, empirical discoveries, to base our faith. They can be suggestive of faith from the eyes of faith or to the eyes of faith, but faith is something, a deeper kind of personal knowledge that we need to cultivate in relationship with the Lord ourselves. At that point, and in the case of those people, it will be, as Professor Lunin is and says, a reason for praise.
Thank you. Professors Lunin and Baglow, on behalf of all of us, thank you very much for your time today. And to all of you, on behalf of the Society of Catholic Scientists and the Science and Religion Initiative at the McGrath Institute for Church Life at the University of Notre Dame, as well as the Harvard Catholic Forum and the Lumen Christi Institute and the Polish Society for Catholic Scientists chapter, I want to thank all of you for being with us today. At this point in time, we want to wish all of you a blessed rest of your day, and we look forward to the next opportunity to discuss with you issues at the intersection of science and faith. Goodbye.